everyone. My name is Kelly Watt. I am a program manager at DFW Airport. Under contract, I have my consulting company, Visual Plan. A lot of familiar faces in the room. Some of that probably from social media. big LinkedIn guy here. I'm going to talk a little bit about the journey to digital twin at DFW. And a disclaimer, I've been on this contract for about 6 months, so a lot of the historical stuff was done prior to me coming on board, but a lot of the direction we're going is due to me working with executive stakeholders and kind of charting out the new direction for the airport. So we're going to talk about some lessons learned, some successes, and where are we going and what kind of data sets we're looking at working with. So my background, former Faro guy, former Trimble guy, was a global director for Faro for a number of years. Had my own consulting company for the last 4 years in reality capture and digital twin. And kind of fortunately kind of came on this project, and it's a really challenging one. Like, the airports are massive, there's lots going on, so it was really kind of a fun thing to take on. I'm going to just play this quick video just to give you a little bit of context of where we are and where we're going with the digital twin program, and then we'll dive right into it. Matt, we have audio? All right.
Ways to care for customers, inspire employees, and strengthen communities. To fulfill our vision of travel transformed, we're making bold moves across diversity, sustainability, innovation, and digital transformation. As part of this vision, we are creating a digital integration platform for the entire airport and have partnered with Willow as our digital twin provider. DFW's digital twin will mirror the physical world, leveraging our digital information to create improved methods to analyze and activate the digital fabric of our infrastructure. Throughout the duration of this program, the digital twin will allow us to analyze and manage multiple assets in a single view. And in time, this benefit will be expanded for a wide range of stakeholders. So far, we've already made great progress, and we'll continue to build upon this foundation. Our journey began with creating the industry's first digital twin of an operational runway and providing analysis of our operational datasets. The next step of the program will deliver new capabilities to the Integrated Operations Center, driving improvements in facility operations and sustainability across the airport. Our vision is guided by the principles of early detection, intelligent prioritization, and the deployment of proactive measures, putting the right information into the hands of the right people in the right location to achieve superior efficiency and operational resiliency. We look forward to sharing further developments from this exciting project as we continue to lead the future of global air transport.
I'll just cut off there at the end there. So, kind of conceptually what we're after is to provide an up-to-date, integrated platform for engineering, for operations, but also for some other areas that you wouldn't think about, like customer experience, passenger travel through the airport. And these things do require us to understand the processes of how we manage different checkpoints, different retail engagements, and such. So the airport is really unique in that we kind of look at data a different way. And there are multiple stakeholders here. From the build, design, and planning side of things, we are a construction site that just so happens to park airplanes at. We have 24-hour construction, 365, and it's something that impacts how the operation of the airport and people flow through that airport. So we need to have good information to make good decisions, and when we don't have good information, it's very, very costly. So the other thing that we want to look at is sustainability, because we do have a big presence in the Dallas area. We're 28 square miles, which, to put in perspective, is larger than Manhattan, which is 22 square miles. So it is truly a city. We have a lot of outlining buildings, utilities, and a lot of things that we're responsible for. And one thing that happens on the air side, and someone backs into a light post, puts out electricity, affects aircrafts coming in, terminals. It's a domino effect. So, and that can reach right back to curbside where we have traffic issues of customers coming to the airport. So there's a lot to think about here, and there's a lot of value that spatial information can provide. So from an environmental affairs perspective, we have to monitor noise, emissions, energy consumption for sustainability goals to get to net zero. We have chemicals that we use for de-icing and on the airfield, and how that could get into water streams is a very significant thing that we need to understand. So topography is important. Containment is important, just similar to the oil and gas industry. So a lot of these things we don't really think about when we think about an airport, but there's a lot going on here. So there's a lot of reasons why spatial information can be important for us. And then obviously the critical maintenance of our critical assets. And assets can be mechanical, which is kind of where we feel comfortable with when we're doing laser scanning, going and doing mechanical rooms, electrical rooms, communication rooms, but far beyond that into airport-specific assets like air bridges. And if we can't get an air bridge out to receive an airplane, that also tremendously impacts our ability to manage this airport. So we have over 500 systems, software systems at the airport. A lot of data silos, over 2,000 employees that serve up to 280,000 employed people as a result of the airport. So a lot going on. So current challenges. Well, we had 28 square miles to BIM model. That's a challenge. And then we have to make sure that information is current over time. That's going to be a challenge. Where do we start? Who do we pick to help us with that journey? What are the standards and governance that we put on the information we collect? Who's going to manage it? So these are a lot of things that we're thinking about. Also picking the right technology to do the job to get what we want out of it. And not overspec. Because if we ask for too much, it costs more, and we may not need that information. We ask for not enough information, we not be able to use that information to do our job. So stakeholder interest is also very broad. I sit in these executive meetings with leadership, and everyone has their own vision of what a digital twin is and what they want it to do. And some of it is kind of out there, shiny objects, a lot of doing our job for us. And a lot of it is realizable too, but there's a lot of work to get there. And a lot of what we need to think about is the data we feed in. And not only the data from the laser scanning and the photogrammetry and the drone data and the BIM models, it's the information that we attach, that we spatially relate. That's really important. And it's the unstructured data that gets lost during the construction handover, or that's on someone's desktop or in a hard drive. Those are the things that we need to surface so that operations has it at their fingertips to be able to respond proactively and do their job instead of hunt for information. So really what this starts is at the standards level and reviewing all our BIM standards and also looking at our laser scanning standards, which are really not that common out there. How many organizations have a document that explains how survey control should be used when we bring a contractor on site, right? So a lot of these things are still new for organizations and for owners. So as you guys are professionals here in this room, and you guys know a lot more than an owner will know, it's really up for you guys to start to educate owners and to help guide them to create standards and best practices so that they get the data that they need. And I can promise you this, the more that you work with the owners to help them, the trust and relationship that you'll build will win you a lot more business than trying to keep the data and the insight in-house. We have a survey department, we own laser scanners, we own drones, we own all of this stuff. We have a Pegasus mobile mapping unit. If we can buy it, we have it. But we still depend 90% probably on our service providers to do the big, heavy lifting. And that's going to continue to be the case. But we need help to understand who's capable and has the experience to do things appropriately so that we get the outputs that we're looking for. And we may need some help even defining what those outputs really need to be so that we don't overspend on certain things. Using the right tool for the job, I think, is really critical. So other things that we have to deal with, the time to value. We're kind of on this quarterly clock. And we get a project started, and these projects take time, right? So getting to the point where we're recognizing ROI and value is really important. So any digital twin program today, before you go out and start scanning and BIM modeling, why? What is the business case? What are we trying to achieve? What savings are we going to have? This is a business that we're doing. We're doing this for a purpose. So that mindset has to be thought about. And I would challenge you to talk to your customers to better understand what they're trying to achieve. Maybe try to help them through that. You know, is it realistic? You know, so if you help them to be successful, they're going to come back for more. And picking the use cases that are most valuable, maybe a little less lifting up front so we can get some initial success and breed on that success, will breed these programs. So that's really important for us. We've started with 4 pilot projects. We scan the Cup. Terminal D, which is our largest terminal, has customs, 2.7 million square feet. We scanned one of the runways and our D-South expansion for the pilot, which has been through the last 18 months here with about 9 integrations to different operational platforms, which we'll talk about. Also at the airport, we have a challenge with competing platforms. I told you how we have 500 different systems at this airport. So, you know, you can spend a lot of money integrating and putting things together, but what's the purpose? Who's going to use it? The other thing that I think is really important, especially from the vendors that are here, sometimes pushing someone to a new platform is not the best way to solve the problem. Sometimes bringing data into an existing platform to augment it can be a really, really valuable exercise. So start to think about what is the workflow that our operators, maintenance people, where do they live today? Can we augment that, or do we have to replace it, right? What lives in a computer maintenance management system, a CMMS? What lives in a digital twin? We've got to think through these things before we just go out and integrate. But the key here is data. And it is data from getting accurate laser scan data so that we can use it in construction, design, and when we have new projects that are always going on. And I tell you, once we scan it, people are going to want to use it. And someone will come back on that work, and they will look at it, and if it wasn't done right, it's going to cause a lot of problems. And I'm going to talk about an experience that we had with that. So visual references for our as-builts and GIS to try to keep those up to date as possible. Our BIM models, these are challenges that we have to look at from a management operational change. How are we going to keep this information current? Points of interest, assets, waypoints, events, observations. There's a lot of things to kind of consider here. And we have both static and live data. We have a lot of things going on at this airport. So how do those things relate? The benefits of digital twins are relating information. So we're relating information to a space where I can point to this light and I can see make, model, number, serial number, whatever I need to know, who's the service provider, what's the preventative maintenance I need to do on that, where do I need to buy it, logistically, how long is it going to take to get it here, resilience, if that light goes down, do they all go down? So all these kind of considerations are important, but when I don't have to go into folders to find information, if I can point to it, grab that information, do my job, and I have all the unstructured data, operator manuals, how to fix it, parts lists, things of that nature, then as an operator, I can do it on the first visit. And when we talk about downtime at an airport, that's really critical. So today, most data is held hostage into data silos. And in particular at an airport where we have so many ongoing projects, so many different project phases, departments, vendors, that we lose data at each exchange. So that's why the standards are important for us to understand how data is needing to flow and moving from a project-centered life cycle to an enterprise life cycle. That information is going to flow into the twin, whether it be updates to BIM, whether it's bringing reality capture into our digital twin ecosystem, or whether it's the information, the asset information, the unstructured data. How's that going to flow? And there are gaps. And there are gaps with departments. Who gets access to what information? One of the things in my interviews I'm asking is, people that are responsible for certain assets have no idea when new information is available, right? And how do you hunt for that? It's in a records management system. So feeding this information at the digital twin will give you real-time information access at whatever level you need it. So why spatial matters? I'm pretty passionate about this stuff. Big part is data silos and removing those data silos by having a centralized way of looking at data and a more efficient way of looking at data. It enables a prepared response that I can see it, evaluate it, discuss internally, possibly consult someone remotely on how we approach a problem before we take the effort to go out and see it in person. And maybe it actually doesn't need a site visit. And there's a lot of opportunity for that. Spatial is natural. We're humans. We walk around, we look at things, we discuss things with people. We understand the world by seeing. So when we try to communicate through an email, a text, calling someone and trying to explain what the problem is, where it is, without that context, you'll lose value. So having that digital twin to use as a communication tool is really, really valuable. And we provide data in context, because a digital twin is more than a virtual representation of the space. It has data attached. And it's not just a single source of data, it's multiple points of data. So when we look at a problem, there could be 2 or 3 things that contribute to a bigger problem. And that root cause is because those 2 or 3 things are happening simultaneously. Well, if we only look at one thing, we may not understand the cause. So that's the multiplier effect of digital twinning and what that value looks like. And we can start to look proactive and look towards a more reliability-focused model. We fixed based on prioritization. So one thing we're looking really heavily about, we had 28 square miles. Where are the work orders? Physically, where are they? You know, we have pavement management. Well, I'd like to fix 5 or 6 of these areas, things that are critical and maybe not so critical, but will be later at the same time. Let's just have one closure. So you start to look at that and the impact throughout the entire airport. That becomes extremely significant. NIST published a study that it costs an organization roughly 23 cents a square foot to find things. The amount of time that we spend searching and trying to figure out things when we could be saving a lot more time. And I'm going to validate that. That's actually pretty accurate in a survey we ran just a couple days ago. So DFW has 2,000 employees direct. We have a lot more contractors, and overall ecosystem, about 228,000 people are employed as a result of the airport. I ran a survey 2 days ago that I've been working on for the last couple months, and I asked a number of these questions. It might be a little hard to read, but the essence of them are we wasting time because we don't have accurate information? And that can be from training to trying to find something and fix it, hunting for information for various purposes. And roughly 50 to 72% of the responding people said they are impacted in some shape or form. That's huge. 50 to 72% of those 2,000 employees, and we're sampling the employees, not the other bigger number, are impacted. So what does that mean? Well, when we look at the colors here, represent to what severity, and I'm measuring severity in terms of the number of hours per week that you waste doing certain exercises because you don't have accurate information, spatial information. So 8 to 10 hours a week represents roughly 20-25% of your work week. And 10 to 15% of our employees are feeling that. Imagine how that impacts an organization that's this large, right? And you can see the numbers at 5 to 8 hours a week. 10 to 25% of our workforce is feeling those pains. And then 1 to 3, we got 25 to 50%. And I just took those numbers as rough based on the questions, just to give you some context. I'm going to be producing a much more kind of comprehensive study on this, and this survey's only been out for a couple days. So it's really important for us to ask these questions and understand the problems, because then it's a much easier task to invest in the spatial needs that we have as an organization. So I also asked a couple of questions just on ROI. Gut feeling, how much do you think we're losing as an organization based on your individual jobs, right? And this is ETAM, which is our asset management team, so this is operations, not construction, and our ITS that do new projects at the airport. I just pulled a couple of the answers, but we're seeing $1 million, $500,000, $100,000. There's your ROI right there. A few people at the airport can justify the laser scan, the BIM modeling, and the other efforts. But if those data sets are looked at as a static data set without the information, and if those data sets are not something that we get access to as an organization, if we don't use the data to do our job, then it's not valuable. So what does a digital twin look like? We've seen a lot of fly-throughs of sexy point clouds. This is the architecture of what a digital twin would look like. They're integration projects, right? So in this, we have BIM models, we have reality capture, and we have other elements. And we display this data in a logical way on the left here that we can understand as humans, and we can pinpoint, and we can troubleshoot. We're working with Parsons and Aurora. Aurora published this on the right here. We have a pretty expansive contract with them on data quality and building an architecture how we collect data, how we store that data in an asset registry that's all of our 500 systems can understand. What is this uniqueness about this asset? What is the relationship? And what is the relationship to the system? And then what integration platforms are going to feed that information into our operational tools, our maintenance management systems, our operational systems, and our digital twin, and our GIS interface. When I came on to DFW, it was really interesting. We had a very mature GIS organization. 20 years, Esri, over 100 layers, really good information. And now we have this digital twin thing over here. And I'm like, well, why? I mean, we're talking about spatial information. We're solving problems using visual context to spaces. So why are these things separate? And they shouldn't be separate. And we have integrated now Esri into the Willow twin. And that's been really valuable. Well, we expose one layer. Well, why? We have over 100 layers. What's going to be valuable for what stakeholder? What can we surface, right? So a lot of that is that kind of questioning why we do things. Now I'm going to bring Matt up to the stage. Matt, if you wouldn't mind joining me down here, I'd like to talk to you guys about a couple of laser scanning projects we recently done at the airport and kind of a lesson learned from a previous experience. You got a mic? Yeah. All right, I'll come over there.
I think I got a mic.
All right. You're going to see a couple pictures of Matt in my slides.
Uh-oh.
So Matt, talk to me about data quality. What does data quality mean to you as a specialist with laser scanning?
I think it's something that, again, I think we've talked about it a lot so far in the conference is you have to look at what is it you're trying to accomplish and reverse engineering, how do we get there? You can see so far from what you've shared in this presentation, you can see how expansive your goals as an airport are. You have to start there and work our way backwards, and the industry is still so early. A lot of us that have been doing it a long time, we don't realize how early it still is. We think, oh man, everybody's scanning at this point. But you look at the organizations who really need the data, and there isn't enough of an understanding to have all these standards in place and know what to ask for. And you have to work backwards, because if we run out and do a project, someone says, hey, go scan this building, and you just run out in there and capture it with something and hand data over, well, what was it going to be used for, and was it captured to a quality that's going to meet the needs of the organization?
And I think that's a really big, a very important point. What are we going to do with the data? But it's beyond the what are we going to do with the data for this project, and kind of let's take a few steps back. What does the organization need to do with this data in the future? What's the expectation? So, rewinding a couple years ago, we had a government grant where Environmental Affairs is working with NRAIL, very advanced project where we're sending information from our sensors to do simulation and get information about how we better run our systems. And mostly like our chiller systems from a sustainability, environmental impact, but also from operational efficiencies. You have hundreds of thousands of people coming through this airport every couple hours. It's really difficult to manage the HVAC systems appropriately. In order to do this, we needed a BIM model, okay? So what are the requirements for a BIM model? I just need a model, right? So let's get it, and how do we need to do it? Well, let's look at the tech out there. Let's look at some websites. Ooh, I like this one. This one looks sexy, right? Shopping malls, high glossy pictures. Let's pick that. So we have a photogrammetry solution that goes through, which really just did not have the capability of managing the data capture of 2.7 million square feet and to convert that into a model. And I think anyone in this room could sit there and say, what the hell were they thinking, right? But at the same time, you have certain business units that have expertise and we're relying on vendors. And the vendors lead us down this path sometimes. Oh yeah, you can do it. I mean, I was the director of Faro. You know, many times I would say, oh, it's so easy, just press that button, right? But we do ourselves a disservice when we oversimplify things. And if we lead the owners into these situations, it does have blowback. So what happened is mid-project, we changed to laser scanning. A lower cost sub was brought into the project. No real proper survey control was added. Certainly more cost was added. We got a BIM model. It was functional for our needs. However, a year later, we need this BIM model for something else, and we need it for a much higher fidelity. Uh-oh. So let's fix it. So Matt.
Yeah, and that's where I think we're starting to see a change. Historically, big organizations, it's been very project focused, right? So you get somebody to come out for that use case. The original scan was done for a certain use case.
Right.
But at now you want to go back to that same data, and it wasn't done properly for what you now want to do. And the cost to repeat the project again to try to get it to that level, it's a lot more headache, it's a lot more cost than it is to do it right from the beginning. And now we're starting to see, and organizations are understanding the long-term value and needing to kind of work on that in the beginning.
Yeah, and don't get me wrong, like we have a long history of laser scanning. We do have good standards, and they're being improved. But there's disconnects in these data silos and project-based needs. And that's what kind of happened in this scenario. And it served the purpose. We were able to accomplish what we needed. But that investment, there was some expectations for that data to be used for other things. So I think, taking a step back, look at the enterprise view, especially when we're talking digital twin, that is what this is, moving from multiple projects to an enterprise current view to be able to manage that information ongoing. So anyways, Matt, talk to me about the CUP project. That's the first project we had you come out. I got some data points on the screen.
That's dangerous.
Told you I got a couple pictures of you here.
Yeah, I see that. Yep. So we got asked to come out and do the central utility plant. And again, I think it was one of those scenarios that had been done in a way before, and it's a very complex facility. There's large admin space. There's, when you get down into the belly of the utility plant, there's layers and layers of piping. There's another screenshot of some data. So the other thing is, I think a lot of the projects at the airport, there's a need to accomplish it quickly at times. There's a lot of timelines that are set, and this was one of those where the initial call and talk about it was, hey, we have a really short time window. We need to figure out how we can capture this whole plant. We have this timeline we're trying to hit. Can we accomplish this with mobile scanning? That was really the first question I got. And so starting to analyze and say, okay, I've never been in there yet. Let's talk about it. We went and visited the site after walking through. I'm like, okay, it's not the right tool for the whole plant. However, it's definitely possible to mix the technologies.
Right.
And one of the most important things, if you're going to mix the technologies, is establishing the survey control. And we've talked about that a lot, and it's such an important piece, not only for the accuracies, but also the ability to integrate those tools easily and plop data together. So the way we approached the project was tying into DFW survey control around the cup, running control around the building, running control into the cup, into each level. There's multiple levels. And then we did the NaVvisWorks scanner for the full exterior of the building, as well as for all the administration, any of the architectural spaces. And as soon as we got down into the mechanical areas, we used the Leica RTCs, and all of those in the processing are tied onto the same control. So we were able to mix the tools to accomplish it as fast as possible, yet still make sure that we're paying attention to the quality of data needed based on what the scope of the project is. So what was the purpose in, the utility plant project?
Well, the purpose is to identify all our assets, all the attributes of those assets, and connect that to real-time building management systems. So with Niagara, JCI, we want to see the telemetry, the temperature and the other sensor information feeding into their digital twin and associate it spatially to where that asset is in the building. So, there's a reason why having high accurate data may also be valuable in the future. We start to talk about physics-based simulation, or we talk about building energy management. So now we need a little bit more accurate data to run those calculations, but that becomes really valuable. And when we talk about simulation, about 70–80% of the lift is in the gathering of data. So why don't we just gather it the way we need to gather it for the scope of the work, but keep it within the confines that we can still use it for other purposes.
Let's go to the next slide.
So, and I have a lot of nice, sexy pictures of this area that we're very much would love to show, but there's we're very cognizant about data security, and we're going to talk a little bit about that in a future slide. But you recognize this guy again, too.
So
Project 2.
This was, so we did the first one, and then we got approached with this next one. So what was the reason we now approached this project?
So this is the rescan effort from our previous scan that we did of Terminal D, 2.7 million square feet. And, we needed to meet this in our 22 budget, or our executives would just be not very pleased. So there was a time crunch. I said, I think originally we had about a month set for this, and that, based on all the decision process, you had, 14 days on site?
Yeah.
So talk to us about a little bit of the challenges that you had there.
Whew. Yeah, so airport terminal, 2.7 million square feet. We get told, okay, this project, if we're going to do it, it has to be accomplished by this date. And that's about 8 weeks out. We're like, okay, that's a pretty good size. Logistics in the airport are complicated. And we're like, all right, well, if it can get kicked off soon, I think we can accomplish it. Logistics to get approval to also get into the airport to do the project they want to do is also complicated. So that took us down to 3 weeks or something like that.
And you were on other projects. You had to move your resources. And
I mean, yeah.
I was at the final button. I said, Matt, if your team is not here on Monday, this project's not happening.
It was Friday. It was Friday.
Yeah.
Okay, can you guys be here on Monday? Whoo! Okay, we're bringing 6 people. We worked 12-hour night shifts for 14 days in a row. And we had escorts that could help us throughout access. And even a lot of people don't understand, and we didn't even understand, how complicated it is, the logistics within the airport, even for the airport, because of there's certain spaces that are owned by different entities internally. And so logistics was the most complicated process.
Right.
But with that time frame, again, we have to reverse engineer and say, all right, how accurate do we need this data to be? And what types of spaces are we getting into? Are we doing every room? Are we doing mechanical? Are we doing terminal? And are we creating models of everything after this? We had to start with, can we use the tools that are fast enough in order to hit that deadline? Because we're really down to a crunch. It would have been impossible, I think, to do the full thing if we went terrestrial. And that's why we took the mobile route.
Yeah, and the data looks phenomenal. I was apprehensive at the recommendation, but I have trust.
I think we have one slide, right? There's just a little snippet.
This is what I'm permitted to show here.
Yes.
So not too exposed, but the control on these large complex projects are really important.
Yes, and that's that's one of the things that was lacking in the initial scan, and again, may have not been discussed as to exactly how accurate it needed to be or whatever the missing pieces were. Originally, before deciding to rescan, the data was handed over and said, can we look at what exists now and see if it's possible to just improve the data? Well, that was about 7,000 terrestrial scans.
7,500
something
scans,
like that, 7,500 scans without control in it. And it was split up into different files, and it wasn't organized in a way that we could say, all right, well, here's all the scans for this area of the terminal. Here's all the scans for this area. So we could go add control and reuse it. it was way too complicated to try to use the old data at that point. So it was, okay, to hit the timeline, our best route is to rescan it. But because that survey was missing last time, that was one of the main reasons that it had to be rescanned in the first place. So our approach to do this was, all right, we're going to use the NaVvis VLX, so we did the VLX for the entire 2.7 million square feet. But one of the most critical pieces was having our survey crews take total stations and actually run conventional survey through the entire terminal,
right,
through the concourse level, to the outside, down into the ramp level, underneath the baggage claims. Because the VLX and other technology, you have to know how much error does it accumulate over a large space. Survey control is one of those things that helps, even with SLAM technologies. You do smaller areas, you add the control in, it helps the accuracy on a large scale job like this actually hit the tolerances that we needed to.
Yeah, don't get me wrong, not all our projects are like this. These are anomalies at the airport. Airport has good standards. They've been recently revised. I've read over them. I thought it's phenomenal. Actually, AECOM is probably credit to give us a lot of help with Robert Lee Brown and really bringing in the best methods for how we approach. But again, when you work in data silos, sometimes that doesn't trickle down. So you have to have a culture of accountability. You have to have a culture of speaking to what is required on these projects, so vendors know. Vendors will only do what you tell them to do.
Yes.
And nothing more. You want me to do this? Okay, you're crazy, but I'll do it. I'll take your money.
Well,
and that's the attitude. We need to shift that and have, okay, wait a second. We don't think that's a good idea. And we've had some conversations where you're like, I don't think that's a good idea. And that's where you build the trust and the relationship with your owners, that they know that, okay, if I talk to Matt, project's going to probably turn out good, so I'm going to use his advice and we're going to get to a good place.
Yeah, and I think one of the challenges still is like even as an organization has good standards and has practices, when you get into larger companies too, there might be scanning going on because of a construction job that somebody else hired a sub, that it's hard to manage.
That's the problem. It's the sub and the sub and the sub. And maybe the prime was, we have a trust level here, but then we also get into concerns about data security. Who's got our data? Did they purge it? Where is it saved? Yeah. But yeah, great conversation about those two projects.
Yep.
And we're going to be doing a lot more scanning. Like I said, we're a city, bigger than Manhattan.
It's huge.
And it's going to be ongoing. So I'm glad that we got some good standards, we got some good data, and we've shared that data with executives too. And that's really interesting. A lot of executives don't get to see the fruits of what they pay for. They see the BIM model, they've never seen the laser scan data.
Yeah.
And it's impressive then to start to see that. But I also want to challenge the industry that, the BIM model is great, but the reality capture has a lot of rich data that we can use to provide context that is forensically accurate, right? We didn't build it, for the most part we got to register it, follow standards, but as humans we're fallible when we have as-built and BIM models, a little bit less so when we have photographs and 3D data. So we're working right now on that integration of reality capture into the digital twin ecosystem. I think it's really critical for us.
And you can see, the reality capture piece is just this much of what the goal of the entire program is. That's where I stop. I'm here to try to help companies fix that piece of the accuracy and how to capture the standards, the subs understanding, and I'm actually going to go back down and let you finish talking about the more important stuff.
Well, not important.
Not more.
It's all
okay,
important.
Not more,
but,
it's all important.
But
this is where it starts going past me. I'm not the data guy.
Fair enough. Well, you're the reality capture data guy.
All right, thank you.
Even wear the T-shirt. So when we look at kind of the architecture of a digital twin, these are some of the core components. So the spatial component, the BIM, the reality capture, the GIS, however we choose to display where things are, is in the center. We have our control systems. We have the historian, the data historian that gives us all the historical data on assets. Up high, we have our work order management systems. Those are absolutely important to understand the history on assets or on fixing whatever needs to be fixed, from pavement to our runways to whatever. Our integrity management, this is our inspections, right? Really, really important to be able to see that information. And our document management system, one of the areas we're kind of lacking right now, where we host sometimes where that unstructured data is located. How do we get access to that at our fingertips? And then we start to layer on intelligence, right? So analytics, machine learning, and how that is going to impact our way to weed through all this mass data. You know, collecting data doesn't actually solve any problems. It actually sometimes brings you more problems, too much to look at. But how do we correlate, how to create some logic here to prioritize and to give us critical feedback that we can act on right away? And the more interesting part with the airports is, how do we deal with people? People going through the airport, how does that impact us? Flight schedules, customer experience, right? Other types of unique environments. So those are things that we need to consider in our strategy for digital twin. So, you know, when we look at full digital twin integration, you know, what we're trying to do is we'll have global search. Global search is important. We can look through a vast array of buildings and find things really easily. Instead of trying to go into our Oracle Unifier and finding a project and try to drill in and find something. We need to standardize the analytics. Look at the data in context, as I mentioned earlier. Looking at automated control on some things, and other things, you know, we got to be really careful on, right? We don't want to get bad actors access to sensitive systems. And we want to be able to look at a third-party ecosystem which is open, because we want to be able to plug things in, because there's no single tool that can provide all of what we need in a digital twin. It's the tool that can integrate with other things that we can solve business problems with. So how did we get here? It's a process. It's not just go out and scan and create a BIM model and fill it full of attribute information and it's a digital twin, we're good to go. No, it's the business problems. It's looking at use cases and discussing and workshopping, looking at ROI. What do we get back if we do it? We need to gather the reference data. We need to evaluate it, improve upon it. We need to see what the gaps are. We need to provide governance and standards. We need to, you know, improve the overall quality of the data before we start to feed it into the ecosystem. So there's an architecture of thinking with a comprehensive digital twin strategy so that we can surface quality data and to the right people at the right time to make good decisions. So what does that transformation look like? And I've used some different maturity models and articles I've wrote in the past. I think this one applies nicely to what we're talking about today, and it was actually produced by the AAAE working group, which is related to airports. So, you know, the standards and governments are at the base. The asset registry, what we have all of our assets related, bringing in the systems integration, and putting these things together into an ecosystem campus-wide as a digital twin. So this is a kind of a rough view of our airport campus. We have individual BIM models throughout this area. There's a lot of gaps. There's a lot of things that still need to be done. As I mentioned, the Terminal D is the key project with the cup and one of the runways that we started with. And we're going to be advancing, actually. We're new fiscal quarter. We're getting our use cases in order, and we'll be out there scanning and doing more BIM modeling and more integrations. So with those 4 projects, we found, you know, some pretty significant value, but also it's difficult for someone to run their business operations when you only have a piece of their portfolio. So there's a lot more work to be done here. So what we've done so far, we've integrated with Esri, with AutoCAD, with the BIM models. So we have basically a Forge plugin that's in this platform that helps us to spatially relate our assets. Hexagon M4 is our CMMS, or computer maintenance management system, that has been fully integrated. But not only one CMMS, we have like 4. As you know, American Airlines has different areas, so we have to pull their data. And we use a different CMMS on the air side. So there's a lot that needs to feed in. But the value starts to multiply when we can look at this data together, right? And we can associate it to a location or an asset. So from the runway, a lot of this is grouping work orders. We won't want to just react. Something is cracking and then becomes an issue. Rubber buildup over here is an issue. So how do we detect that early? How do we monitor it? How do we associate and group those work orders so we have less closed runway time? We need to fix these, between the wee early morning hours. 1, 2, 3, 4 o'clock in the morning is when they can do service on this kind of stuff. So there's a lot there if we can relate it. And the BIM model itself is not going to solve our problems, because when I'm out there and I find a problem, I still need to relate that. I need a GPS. I need to know where it is. Where is that tied to that panel? We want to see the construction history on that, because when we poured the concrete, it may have been impacted based on the weather conditions. So maybe I can associate how during construction we laid a layer, and we can say, well, we're having problems over here. We're likely going to have problems over here because they were laid in the same conditions. So it's getting, kind of proactive in how we address problems and group those problems to be more efficient, that are going to be really valuable. We have all our electrical on the runway, the lighting systems we have to manage. And a lot of this is guys driving around in trucks looking for problems. So how do we automate that? How do we create efficiencies? We need to first know where it is, what it is, and then how do we monitor, is it going to fail early, or is it failed? And then how do I send one person to go fix those 3 or 4 problems instead of sending different people all over the place? And we have a integrated ops center. This is the heartbeat of the airport. Every business unit is represented. This is actually relatively new to the airport. So you have people up here managing multiple systems, making real-time decisions on how we respond, prioritizing. Based on that spatial information, it gives us a lot of context. We need to understand where our resources are. Where are our people, and who should I dispatch to where? It's another problem we're looking at right now. Spatial, real-time, operational data. So whether it be from a sustainability, energy management, or whether it's a reliability focus to make sure we extend our lifeblood of our assets. We have a lot of expensive assets. So we need them uptime, and we also need to make sure that we're not wearing them out too fast. So when I first came on to Dallas, I started to look at how we're managing data, and I see some gaps. So right now we're going through an audit to review how we manage data, how our partners manage data, and where does that data reside afterwards? And I think this is a really important one for everyone in this room that does laser scanning, is because we usually hold on to that data, don't we? Especially if we get some cool data that might want to show in a presentation. We've got to be very, very careful with this. The systems we have at DFW to protect our data, we spend a lot of money on. The systems that some of this audience have don't have that same type of security built in. And there are a lot of bad actors right now. Just last week, on October 10th, we had major airport attacks, cyber attacks, that happened and breached 13 major airports. And this is happening on an everyday basis. So what happens if your data on your unsecured server is accessed because I'm a bad actor and I knew you won the contract? And it's easier to breach you than to breach DFW. And how do we use that data in a nefarious way could really come back. So I just encourage you to be very ultra vigilant with how you manage data and be very careful with it, with the understanding that we know our owners don't really manage data very well. How many times have you guys been asked for you to give data back to your owners after a project? I lost it, didn't know where it was, didn't have access to it. So speaking with the owners to help them find a better way to manage their own data, to make sure there's some resilience there, you have some confidence to purge that and not have to have custody of it. So this is an important one for us, and I want to find some good solutions to kind of improve the way we're managing, especially our reality capture data. I think it's so valuable that we can use this and reuse it and not have to laser scan all the time. And the more efficient we are, the more we're going to use it, right? The more we're going to contract because we get more bang for our buck. So areas I'm looking at right now, real-time passenger flow, expanding our utility mapping, which includes our subsurface mapping, and the underground utility tunnels that reach from our cup to our 6 terminals. Customer experience, how to optimize that from too hot, too cold, too light, too dark, and just how we have enough seats, these types of things. So sensors can give us that information. and we can start to route people more appropriately. And getting more of our critical assets on board, our air bridges, our conveyances, et cetera. So looking forward, this is not something we're doing at the airport, it's something that I think is really fascinating. You've seen a little bit of this from Preview 3D in terms of running real-time movement sensors through a digital twin. This is another company out of Europe called Twinzo. You actually go on your phone, you can download their app and play with the data. I think it's fascinating. I can see the forklifts running around, I can see the battery level, I can see process flow relates to the 3D space. It really is a fantastic way to consume information. And I'm envisioning big screens like this in our utility cup where operators can come up, touch things, evaluate things, make decisions in real time. And a part of the digital twin is getting access. I can't expect our operators to go on their laptop and pull something up. They need to have a tablet in hand. They need a screen in their office. So again, if we build it, we don't give access to operators. If they don't touch it, they don't use it, what value is it? So on the right side, we see video cameras monitoring movement and then replicating that in a twin. Pretty cool stuff. Now I'm going to leave with this video on NVIDIA's Omniverse. I don't know, half of you guys may have seen this and some of you may not. I think it's quite mind-blowing of where we're going, where we can go with the technology.
Welcome to BMW Production, Jensen. I'm pleased to show you why BMW sets the standards for innovation and flexibility. Our collaboration with NVIDIA Omniverse and NVIDIA AI leads into a new era of digitalization of automobile production.
Fantastic to be with you, Milan. I'm excited to do this virtual factory visit with you.
We are inside the digital twin of BMW's assembly system, powered by Omniverse. For the first time, we are able to have our entire factory in simulation. Global teams can collaborate using different software packages like Revit, CATIA, or point clouds to design and plan the factory in real-time 3D. The capability to operate in a perfect simulation revolutionizes BMW's planning processes.
Are those gaskets still in the right place for you?
Yeah.
BMW regularly reconfigures its factories to accommodate new vehicle launches. Here we see two planning experts located in different parts of the world, testing a new line design in Omniverse. One of them wormholes into an assembly simulation with a motion capture suit, records task movements, while the other expert adjusts the line design in real time. They work together to optimize the line as well as worker ergonomics and safety.
Can you tell how far I have to bend down there?
So we'll get you a taller one, but there's...
Yeah, it's perfect.
We would like to be able to do this at scale in simulation.
That's exactly why NVIDIA has Digital Human for simulation. Digital humans are trained with data from real associates. You could then use digital humans in simulation to test new workflows for worker ergonomics and efficiency. Now your factories employ 57,000 people that share workspace with many robots designed to make their jobs easier. Let's talk about them.
You're right, Jensen. Robots are crucial for a modern production system. With NVIDIA Isaac Robotics platform, BMW is deploying a fleet of intelligent robots for logistics to improve the material flow in our production. This agility is necessary since we produce 2.5 million vehicles per year. 99% of them are custom.
Synthetic data generation and domain randomization available in Isaac are key to bootstrapping machine learning. Isaac Sim generates millions of synthetic images and vary the environment to teach the robots. Domain randomization can generate an infinite permutation of photorealistic objects, textures, orientations, and lighting conditions. It is ideal for generating ground truth, whether for detection, segmentation, or depth perception. Let me show you an example of how we can combine it all to operate your factory. With NVIDIA's Fleet Command, your associates can securely orchestrate robots and other devices in the factory for mission control. They can monitor in real time complex manufacturing cells, update software over the air, launch robot missions, and teleoperate. When a robot needs a helping hand, an alert can be sent to mission control, and one of your associates can take control to help the robot. We're in the digital twin of one of your factories, but you have 30 others spread across 15 countries. The scale of BMW production is impressive, Milan.
Indeed, Jensen, the scale and complexity of our production network requires BMW to constantly innovate. I am happy about the tight collaboration between our two companies. NVIDIA Omniverse and NVIDIA AI give us the chance to simulate all 31 factories in our production network. These new innovations will reduce the planning times, improve flexibility and precision, and at the end, produce 30% more efficient planning processes.
Milan, I could not be more proud of the innovations that our collaboration is bringing to the factories of the future. I appreciate you hosting me for a virtual visit of the digital twin of your BMW production. It is a work of art.
So has anyone seen that video or know much about Omniverse? Pretty fascinating stuff, isn't it? And when you look at the leaders in digital twinning, it really is the manufacturing industry that have been doing this a long time, process manufacturing, oil and gas. So you can kind of borrow some of these concepts and insights of how they're managing their data. But I wanted to thank everyone to listen to me here today. Hopefully we were able to show some new and interesting things. And if you would like to connect to me on LinkedIn, that's my profile. I did write a provocative article on what a digital twin is, and I think if you don't read it, you might get a bit annoyed, but then when you read it, you'll understand my point. That reality capture is just that. It's not a digital twin on its own. It's a huge part of what a digital twin is. And I don't want my message lost on that, but I think understanding a little bit more about the complexity and what we're trying to solve will give you a better understanding of what digital twins are. Thank you.